Welcome to the ThinkRF webinar on lowering total cost of ownership, so-called TCO, without sacrificing performance of RF solutions for end users. Next slide, please. So in order to try and illustrate this, one of the things we've done is to try and compare three approaches. You can build your own RF spectrum analysis equipment from scratch, or your solution from scratch. You can purchase a traditional hardware-based lab spectrum analyzer, or you can purchase a software-defined spectrum analysis system based essentially on a platform that allows for that exploitation of versatility associated spectrum analysis, software-defined spectrum analysis platforms. So those are the three approaches we're going to compare. So how do you decide which approach is best for you? So what's best for your project? Next. So in order to sort of try and compare these things, what we've tried to do is to consider certain factors here. So obviously cost per analyzer is important, time to market is important, having the domain expertise to be able to deal with the particular industry you're working in is important. Standardization is also important, and integration effort is also important. So these are some of the factors we've tried to build into the comparison here to try and allow for essentially a fairer comparison of the three approaches to building systems. So just to set the scene here, so what we've done here is we've made an assumption that each solution is going to require essentially 25 units of receivers, and we've tried to standardize that across the three approaches so we can do a sort of an apples to apples type comparison. So what we're looking at here with the first approach is essentially building your own. So we're looking at an approach here that's suitable for projects that require a larger volume of units, right? So the product can be incorporated into the standard product offering, and that allows for an approach that suits the needs associated with those factors. Now, the issue there is the cost per analyzer tends to be high. Your time to market is a lot longer and tends to be at least 1 to 2 years as you develop and build your own. Your domain expertise you may or may not have, and so that's marked as a high requirement there. And then your ability to integrate also requires a certain amount of effort. The approach here is essentially building your own. So customized projects essentially do mean that you can't meet those requirements through off-the-shelf type equipment or COTS. So you would have to try and build your own here. So if you have the luxury of time to market and if the luxury of a cost per analyzer, then this can be a suitable approach for you. Thanks. So again, building on the assumption that you've essentially got 25 units that you need to put into your system here, we've made some assumptions around how much time it's going to take to develop. We're saying that there's roughly 9 months of development time for 5 people, essentially, which is where the costs come in. And what comes out of that essentially is a bunch of development costs associated with the units, and the total cost there of somewhere between, depending on the scenario you take in terms of the price, etc. It's somewhere between 1.8 and 1.9 million, so approaching $2 million overall, and that works out to a per unit basis of somewhere between 72.5K to 77K per unit. Next. The second approach is to basically try and purchase traditional hardware analyzers. So working with what's already out there. So this is really suitable for where you need, where you have requirements which require high performance needs from an RF performance, a high RF fidelity requirement essentially. And here is where you would use essentially higher cost analyzers, and the cost per analyzer then tends to be high. On the other hand, you've got a situation where, because these things are already commercially available, the time to market tends to be lower, and you don't need the domain expertise from an RF perspective in order to achieve what you're trying to do. However, standardization and integration effort tends to be higher, right? And that also has a cost impact. So, there are end users out there who might demand a certain vendor's equipment because of their own needs. So that's an approach that this would look at. And then there may be a lab-based application where the units will be stationary. So these are particular applications where the portability factor is not really coming in. It's really a question of what the particular application needs are here. Next. Right. Again, so looking at this from an analysis perspective, assuming again 25 units, you end up with an integration cost essentially of associated with 480 hours. Bottom line is your total costs end up being between 1.5 to 2.5 million, and that works out to a range of roughly 64K to 104K per unit on a cost basis here. So there is associated increase in costs associated with integration, etc. The price per units are a lot higher because they're off-the-shelf, high fidelity type analyzers. So that drives the overall cost higher. Next. The third approach, of course, is to look at this whole system based on a software-defined spectrum analyzer platform. Now, this is pretty suitable for situations where you've got applications in a variety of industries and use cases. So you've got a variety of deployment scenarios which range from stationary type deployments to remote deployments to mesh type deployments. So you need the versatility there. And then, you have RF solutions which require hardware and software essentially meshed together from different vendors. So the software-defined approach allows you to do that. And again, as I said, you could have these in a mobile type environment or a static network. And overall, the cost of the analyzers tend to be lower. The time to market is lower as well because of the availability of these particular platforms. Domain expertise you don't need from an RF perspective. Integration effort tends to be lower. So when you look at these factors in here, then you can go to the next slide and look at some of the cost analysis associated with that. So again, looking at 25 units, what we've also done here is to look at putting in a down converter. So in other words, if you have to go to higher frequency ranges as well, so that basically bumps up the cost requirements as well to a certain extent. But we put that in just for an apples to apples type comparison to allow you to judge this on that basis. So an example of this would be, if you have analyzers based on a frequency range of 6 gigahertz, for example, by putting in RF down converters that allow you to go all the way up to 30 gigahertz or even 40 gigahertz, will actually reduce the overall burden on your long-term costs for higher frequency equipment. So we look at this, we're assuming 25 units within an environment. The integration costs tend to be a lot lower. The price per hardware is between 25 and 40K, depending on whether you have the RF down converter in there or not. And then your total cost, if you look at that, it's somewhere between 660K to just over 1 million. And that breaks down to a per unit cost of somewhere between 26,000 and 41,000. So if you try to compare all of these approaches and look at the total cost of ownership for system integrators for each one of these approaches, so buying your own analyzers on the left there, and what is showing there is what's shown in gray there is the minimum cost, and what's shown in orange is the maximum cost. So when you're buying your own analyzers and it should be developing your own analyzers actually. So when you do it that way, then your costs are actually between 1.8 and 1.9 million. And buying traditional analyzers and using that approach, which is approach 2 that we looked at, it's somewhere between 1.6 and 2.6 million. And then we look at you're basing your solution on software-defined analysis platform. It's somewhere between 500,000 and 1 million. So overall, it's very advantageous, depending on your needs, of course. It's very advantageous to go to a software-defined approach. So again, the software-defined approach has a lot of advantages, not least being the cost approach, and especially for system integrators. So, you've got the versatility associated with the different APIs and programming environments. You've got the ability to mesh together and mash together the different softwares and hardware capabilities that you need within any particular solution. So that overall allows you to develop a solution that is much more cost-effective and versatile. Next. You have again, factors that go into reducing this lower cost of ownership is the price performance ratio that's available. You have a pretty good RF performance based on for the particular price you're getting. So that ratio is pretty advantageous. You have a lower price for the end user. It allows for flexibility and versatility and the ability to meet feature requirements coming through, such as 5G, and allows you that approach. And then finally, not least, actually, is it improves the ability to integrate with the softwares that are out there that may or may not suit your needs, either with needing third-party hardware software requirements, or even having to develop your own software. It's a lot easier on a software-defined approach than any of the others. Next. So in terms of what ThinkRF provides, we have the whole gamut of provision, if you like. We go everything from real-time spectrum analyzers, which are essentially headless, highly integrated analyzers based on a front-end analog system with a back-end digitizer, and it allows network ability through a GIGI interface as well. So that's the spectrum analyzers themselves. Then you've got the RF down converters, which are highly configurable and essentially tuners that allow you to go up to higher frequency range and down convert to a frequency range within the existing capabilities of your existing equipment. And it has capability. It's all based on Skippy commands, so it has the ability to support third-party high-end digitizers as well. On the spectrum analysis application side of it, we do have our own proprietary software. But we do work with other software vendors as well, notably Keysight signal analysis, vector signal analysis software. And we're actually the only hardware company to integrate our hardware with the Keysight BSA. And then, of course, there are a number of other third-party analysis applications and software applications for everything from technical surveillance and countermeasures all the way to signal intelligence type of applications to look at complex waveforms and interference hunting, etc. as well. And we've put together a fairly comprehensive API and enabler system that allows for the environment for you to create your own applications on top of that if you need to. So versatility, from a versatility perspective, it makes sense to have those APIs available for programming environments such as Python, C, or MATLAB and LabVIEW. And that allows for the versatility that you would need within your own application needs, especially for your end user. And a lot of it is based on standards such as Skippy and VitaVRT type approaches. And as I said, we're also looking at we have implemented actually IVI and iSlip as well. So that's something else that's very important to know. Next. So from a system integrations point of view, system integrator point of view, having the increased amount of flexibility is really important through the open APIs, through the program integrations. It allows you to build those complete solutions you're trying to build. You can get a greater amount of coverage using the compact form factors. So you can basically cater to a variety of deployment modes, whether you want to do it remotely and monitor, or you want to create some sort of mesh network, etc. So that increases the level of coverage you can achieve. The functionality is really based on the feature richness of the hardware and some of the software that's out there. So you have the ability from an RF perspective to develop to detect and deal with those complex waveforms coming in real time. So you've got standards, new approaches coming in with complex waveforms. You've got the 5G stuff that's happening below 6 gig, above 6 gig, etc. So all of those things are pushing the envelope in terms of functionality requirements, which a software-defined approach can certainly help. All of this actually leads to a better ROI in general, because you can upgrade, you start off from a lower cost base as we've shown, but your upgradability and versatility to upcoming changes and ability to adapt to new environments becomes a lot more. It's a lot stronger. So not just stronger, but also it lowers the cost of the implementation of those approaches as well for those new standards. So overall, the lower cost essentially leads to a better ROI. There's a lot more information on our website, so I'll point you to thinkrf.com, or if you want more help on a one-on-one basis, then certainly contact us on info@thinkrf.com. Thank you for watching.